A very good afternoon to everybody. My thesis proposes a pathway to diagnose cancer at an early stage. Now, how do I achieve it? My first step was to synthesize gold nanoparticles electrochemically. Nanoparticles are the teeny tiny particles of size from 10 to the power of -9, and they're only detected under an electron microscope. Me being a physical chemist, I went on to do one of the neatest and cleanest way of synthesizing these particles, which is electrochemically. By electrochemically, I mean I use electrodes, potentiostat, use a potential to reduce my gold salt, as you can see from the first graph at the top, from gold 3 all the way down to gold 0, which is the metallic state of gold, and hence forming nanoparticles. Now, getting to make these nanoparticles is not the important step. The key point is to make them as long as you can, as pointy as you can, and I made dagger-like nanostructures which can be used for molecular imaging because they have an enhanced signal capacity. So the particles that you see at the extreme right are the nanodaggers. The longest arm was 700 nanometers. Well, compared to the other scales, they're still small, but under nanometer scale, they're good enough. More the pointy they are, more the tall, longer they are, more dagger-like structures they are, greater is their intensity in signal, as you can see from the blue, the second image at the center where you see the blue signal. The enhancement factor is way higher than that of the red signal that you see, which is without being those spiky nanodaggers in there. Now, when you can put this into molecular imaging, how is it so important to, or how is it possible that you can diagnose cancer at an early stage? So the future perspective is to conjugate these nanoparticles with peptides. You put them into human body. What happens is that cancer cells, they would have, they're very deceptive. They're very naughty. At times they mimic natural cells. But these conjugated stuffs with nanoparticles and peptides, they can bind, they have a greater binding affinity with receptors which are overly expressed by the cancer cells or carcinomic cells. So that can help in molecular imaging and hence therapy. Is it far important than other imaging techniques? Yes, because they're very deceptive. They can mimic natural cells. At times therapy is not possible. You cannot diagnose it. But I'm sure that when you have these particles, they can really catch and kill the cancer cells. Thank you for your attention.